Then if we're thinking about the definite integral, so we've just looked at the indefinite, let's look at the definite integral. So our definite integral allows us to find the signed area bound by a curve between two limits. Okay, so that's what makes it definite, that we're doing it between an exact interval. So say here we're finding the area between 0 and 2 underneath the curve here. Okay, so we're finding the area between the curve and the x-axis. So areas above the x-axis will give you positive numbers, whilst areas below the x-axis will give you negative numbers. Okay, that's because when you integrate them, if they're below the x-axis, you're integrating with negative y values, and above the x-axis, you're going to have positive y values, which is where you get positive area, negative area. Okay, and you can think about that, like say if this was like a square and you had to easily find the area of it, you'd be multiplying like whatever this positive y value is by the x length, which will give you a positive number. But if we were doing this, we'd be multiplying like negative by the positive x length as well. Okay, so to help you sort of understand what this has to do with the definite integral, let's say that we've got this curve and this green area has an area of 4, this yellow one has an area of 3, and this pink one is going to have an area of 2. If you were asked to find the area bound by fx and the x-axis between the points A and D, what you would actually have to do is do 4 plus 3 plus 2. However, if you were actually just doing this using your integral symbol, your calculator would actually consider your 3, your negative 3, as negative. It wouldn't account for the fact that you're actually trying to find area. Okay, so this is why we have to use or evaluate definite integrals using the second fundamental theorem of calculus. Essentially what that means is if we are trying to find the area of something between B and A for fx, if you're trying to find the area between these 2 points, you actually have to find it using big F, so the primitive of B minus the primitive of A. And you actually have to minus the primitive of A to account for the fact that this area is going to be negative. Essentially thinking about like 2 negatives make a positive. So if you do it like this, you will get the proper area and you'll be actually like adding area on rather than taking it away. Okay. Hopefully that makes sense. If it doesn't make sense, ask questions in the chat. Otherwise, we will keep moving on. So the other thing you can do is when you're dealing with definite integrals that have symmetrical limits, so essentially if your f of x is an even function, then to find the area between a and negative a, if we're using this example per se, all you can do is do 2 times a and 0, okay? Just makes it a little bit easier, less area to find, and you just multiply it by 2, okay? But this is only if they're exactly symmetrical, okay? Then if we've got an odd function and we've got they're symmetrical with an odd function and we've got a here and a there, if we're not trying to find the area and we are just trying to find the actual value of the integral, then the symmetry on an odd function means that between a and negative a, our function will actually equal 0. Okay, remembering that this is, with the odd functions, the symmetry only works if you're not trying to find the area, just like you're actually just trying to find the value of this integral. All right, so I'll give you guys a minute. We've done sort of a bit of a rapid fire of integrals, so I'll give you a minute, have a go at this, and we'll see how we go from there. Alrighty, so with this question, first thing to consider is the fact that the question is just asking you to find the value of the integral. It's not asking you to find the area. Now, this question stumped a lot of people for that reason, in that they thought that because you were given this, and they were talking about area up here, they thought that the question was asking you to find the area, which it's not. It's just asking you to find the value of the integral between 2 and -2. In order to find that integral, we're thinking about each of these areas, you actually want to consider as -3/2, and then each of your A areas as 1/2, okay? This is an even function, which means that we know that this is going to be exactly symmetrical. So in order to find the value from 2 to -2 of fx, you do -3/2 plus a half minus 3/2, which will give you -2 as your final solution. Okay, so now looking at finding areas bound between two curves. So you can find the area bound between two curves between two values. So B and A can be any two x values. B, just a little side note, always remembering that whatever you put on top is the bigger x number, and then whatever you put on the bottom is the little x number. Again, to me, that sort of makes sense. Like the bigger number goes on top, the little number goes on the bottom. But in order to do that, to find the area bound between two curves, all you do is f of x, so the area of the function on top, minus g of x, which is the function on the bottom. Okay, so if we're considering this one here, our f of x is whatever function has the line on top, g of x is the function with the line on the bottom. And then in order to do that, you literally minus f of x, so whatever the actual equation is for f of x minus the actual equation for g of x, you get one final equation that you can then integrate between the limits. Okay, this is best, I think, explained through an example. So I'm actually just go through this example because this is like a new concept and I think it's just easier to explain like this. So this is from the 2022 HSC. So the parabola y equals x squared meets the line y equals 2x plus 3 at the points -1 and 3, 9 as shown in the diagram. Okay, if they don't give you a diagram, always try and draw it if you can. Unless these are really complicated equations, I would always try and draw the diagram, especially when you're trying to find areas between two curves so that you can actually see which one's the top and which one's the bottom. So find the area enclosed by the parabola and the line. Okay, and they've been very nice and they've given you the points as well. Sometimes if this question was, I guess, a bit further on in the paper, they probably wouldn't give you these points and they wouldn't give you the diagram. You'd be expected to draw the diagram, find the points that they intersect at as well. So in order to find this area, we use our x coordinates. So we've got 3 and -1, and we literally minus the two equations from one another. So we've got 2x plus 3 and x squared. Now our 2x plus 3, that straight line is on the top. When you're thinking about which function is on the top, you're literally considering which line is above the other one. So we do 2x plus 3 minus x squared because the x squared was on the bottom. Once we've done that, we then integrate it. So we do 2x squared on 2, which gives us just x squared, plus the 3x on 1, which is just 3x, minus x cubed on 3, which we can't simplify, between 3 and -1. From here, we then substitute 3 into each of these x values, and we'd get 9 plus 9 minus 9. Subtract whenever we find our definite integrals. What we do when we put -1 in. So if we put -1 in, we get 1 minus 3 plus 1 and 3. Pop that in your calculator and you'll get the area is equal to 10 and 2 and 3 units squared. Remembering, you are finding area, so you do need to have units squared, unless they've given you centimeters, meters, kilometers, whatever. Otherwise, the safest bet is to do units squared. Okay. So there's one more thing we're going to look at with integration. So when we don't know how to integrate a function, we can still sort of approximate the area bound by the curve using a trapezoidal rule. So this is when we've got complicated functions that we don't have a rule to do integration with. So we first want to think about a trapezium, okay? So we're looking at the trapezoidal rule, so of course it's going to have something to do with trapeziums. So if we have a trapezium, maybe it looks like this, the area is equal to a half h times a plus b. Or you may know it as a plus b on 2 times h. Either or, these are the same thing. So the trapezoidal rule involves approximating the area bound by a curve into several trapeziums and then adding their areas up. Now this seems a little bit random, but let's say this pink situation here is the graph of y equals fx. We can divide this into a whole bunch of equidistant trapeziums. So if we've got x1, x2, x3, b just being like our final limit, we can divide this into equidistant trapeziums in order to help us approximate the area of our graph. So in proper terms, using the trapezoidal rule to find the area of fx between b and a, all you want to do is b minus a over 2 times n, where n is like your number of subintervals or how many trapeziums you've put in. So let's say here we've got like 4 trapeziums. And then we do f of a, where f of a is our first number, plus f of b, where f of b is the value of y, and the final number, plus 2 times the values of each of the things in the middle. Okay, this seems a little bit complex. So in a simple form, the trapezoidal rule is h on 2 times the first plus the last, plus 2 times the middles. Okay, where h equals b minus a on n. Okay, this all may seem a little bit complex still, and a lot of people really don't like the trapezoidal rule, but we'll just look at an example so you get a bit of a picture of this. So when we're thinking about this question, it says use 2 applications of the trapezoidal rule to find an approximate value of root 1 plus x squared dx between 2 and 0. Give me your answer to 2 decimal places. First things first, this trips a lot of people up. 2 applications means that you're creating 2 trapezoids. 2 trapezoids means you're going to have 3 x values. And 3 trapezoids means you'll have 4 x values, and so on, so on, so on. So in order to answer this question, if this is what we're trying to find, what we want to do is create 3 x values that are all equidistant from one another. So in this case, pretty easy. We've got 0, 1, and 2. They're all 1 unit apart from each other. Then what we want to do is substitute in each of these values into our fx. So we'd get 1, rounded off 1.414, rounded off 2.236. Then all we need to do here is do a half, okay, which is essentially what you're doing here is b minus a divided by 2. Okay, so this is b, a divided by 2, you're going to get a half of 1 plus 1.41, which is these first 2, and then a half times 1.41 plus 2.236, and that gives you 3.03 to 2 decimal places. Okay, so we've got this, which is our h on 2, so that's half is h on 2, and then we've done only multiplied the 1 once, only multiplied by the 2.236 once, but 2 multiplications of the middle. Okay. So that is integration for you. Not a whole lot to it. It's pretty much just using rules to answer questions. So once you do a lot of practice, you will get your hands around it pretty quickly. So